Hi DAs, welcome back to another episode of Blast from the Past. Previous year question discussion from the JEE Advanced paper. Which question we have now? 2019 paper. We have a question from 2019 paper. Let's go through. Wow, that's a beautiful question. The correct order of acid strength of following carboxylic acid. All of you know how the acid strength of carboxylic acid is decided. It is based on the group connected to carboxyl group. Here we have ethyne group. This is ethyne carboxylic acid where the carbon is sp carbon. Here we have ethene group which is sp2 carbon. Here we have substituted benzoic acid and there is a methoxy group. There is electron withdrawing group, methoxy group connected to the benzene ring, and that comes next. And of course this is also carbon which is sp2 carbon. And here we have propanoic acid, 1, 2, 3 propanoic acid, and this carbon is sp3 carbon. So why we are commenting about the hybridization of carbon? Hybridization of carbon is very, very important, no doubt about it. Hybridization of carbon plays a vital role deciding the acidic strength of carboxylic acid in this situation, because this is sp carbon which is more electronegative. Sp carbon which is more electronegative, and the presence of more electronegative electron withdrawing group, this will act as a more powerful electron withdrawing group, and quite naturally sp2, sp3. The sp carbon which is more electronegative will be more electron pulling in nature. The electron withdrawing groups, all of us know, presence of electron withdrawing group increases the acidic character. RCOOH, the nature of this group, if it is electron withdrawing group, acidic character shoot up. If it is electron donating group, acidic character drops, isn't it? So sp carbon available in the first case, it will be more electron pulling in nature, electron withdrawing in nature. So that will be most acidic. So one maximum means we are going to throw away option 2 and 3. One maximum we have. After 1, which will be? After 1, is it 3 or 2? Is it 3 or 2? You see the pKa value, ultimately pKa value will decide the acidic strength, right? The pKa value for this is less than 2. The pKa value for that is less than 2. That is the least figure, 1.8 or 1.9 range. That is the pKa value for that, and that will be maximum. One maximum, no doubt about it. What about this and this? This and this, when you compare, this is having a pKa value, it is in the range of 4.3 range, while this is having a pKa value 4.5 range, and hence it will be 2 second place. After 1 it will be 2. After 1 it will be 2, and hence we conclude our answer, it is fourth choice. 1 maximum, then 2, then 3, because there is a confusion. This is sp2, this is also sp2, both are sp2 carbon. Of course this is last, having a pKa value 4.8 range, 4.8 or 4.9 range, just below 5. That is a pKa value for propanoic acid, and that will be last, no doubt. A doubt between 2 and 3. Okay, and you know that is mainly due to this electron donating group present with the benzene ring. Suppose it is benzoic acid given. Suppose it is given benzoic acid, where it will come. Suppose it is given benzoic acid without any group like methoxy. This is methoxy group, electron withdrawing group. Presence of electron withdrawing group. Electron donating group. This is electron donating group. Electron donating group. Presence of electron donating group will decrease the acidic character, isn't it? So definitely when you compare this and this will be more acidic. The presence of electron donating group, methoxy group, will decrease the acidic character. So please understand, when you compare this and this should be maximum. What about this and this? There can be a doubt, no? This is sp2 carbon, this is also sp2 carbon. What will be the nature of acidic character? Please understand. Suppose there is benzoic acid given, that would have come prior to this. The value for this is 4.2, sorry 4.3. The value for this is somewhat 4.2, slightly lesser. So this is more acidic. Benzoic acid is more acidic than ethene acid, ethene carboxylic acid. Is it clear? Is it clear? That is point number 1. So suppose this acid is not given, simply benzoic acid given, it would have come prior to this. Hope you understand. Now, another important point. Suppose this group is given like this, what will be the nature? Suppose it is given COOH. Instead of methoxy in the para position, suppose methoxy given in the meta position, sorry, ortho position. Ortho-methoxy benzoic acid. The story is entirely different. The story is entirely different. Please understand, this is more acidic than this. If this is 4.2, this will be in the range of 4.1. Got the point? Got the point? What is the reason? What is the reason? Taught in the classes. Exactly. Ortho effect. Due to ortho effect. Due to ortho effect, any group, whether electron donating or electron withdrawing group, coming at ortho position, the acidic character shoot up. Isn't it? So due to ortho effect, suppose the same methoxy group given at ortho position, that would have been prior. Even prior to benzoic acid if it was given. Is it clear? Is it clear? Okay, fine. Suppose instead of methoxy group, it is given nitro group. What would have been the nature? Suppose it is given nitro group. There is COOH and there is NO2 given. Please understand, electron withdrawing. NO2 group is electron withdrawing in nature. Acidic character increases. Acidic character increases. Please understand, pKa value is somewhat 3.4 range. 3.4 range, and that is much more acidic than benzoic acid if it was given. If it was given. So para-nitrobenzoic acid more acidic than benzoic acid. Perfect? Perfect? And now once again, what about ortho-nitrobenzoic acid? Suppose it was given ortho-nitrobenzoic acid. What would have been the order? Ortho-nitrobenzoic acid. Suppose the NO2 group is given here. See, there is electron withdrawing effect and ortho effect. Electron withdrawing effect and ortho effect. You know the pKa value comes out to be some 2.2 range. And that will be much more acidic, but still less acidic than this. So suppose all these molecules what I have described in the screen is available. This will be most acidic. Less than 2, 1.8 or 1.9, that is the range. And after that it would have been this one, ortho-nitrobenzoic acid, which is 2.2, slightly above 2. And after that it will be para-nitrobenzoic acid, 3.4 range. Clear? Fine. Because it is electron withdrawing in nature. And after that it would have been ortho-methoxy benzoic acid, ortho effect. Right? After that it is benzoic acid. After that this. After that this. And finally this. That will be the order of acidic strength. Right? I am going to wind up with one question that I am leaving to you. There is an abnormal scenario. Suppose you are taking this molecule or any of these such molecules. Suppose you are taking this. The pKa value is 3.4, right? 3.4, right? What is its behavior when you take in DMSO? Suppose the same molecule taken in DMSO. You know what is DMSO? You are learning that. Dimethyl sulfoxide. The same molecule taken in DMSO. The story is entirely different. What is that story? I am leaving to you. We will meet in another episode. Till then, bye. See you.